Hi guys, my name is Ivo and I'm from My Tested ASP.NET. In my previous video I showed you my algorithm which compares objects deeply, and I told you that we're going to enhance the algorithm to return where the problem is and what's the difference. So we're now going to start implementing that. But first, I would like to tell that I will I will I will want to have two different versions and overloads of this method. One of them needs to return true or false just to make sure everything works, because as you can see I'm using this method in 80 references, so I'm going to introduce a new version of the methods, but all the previous ones are going to continue working. But first, let's start with the algorithm itself. So I need to start from here. Good. I already did an object which is going to save our process, and we'll have the result, and that's this object which is called deep equal result. Its whole idea will be to contain all the paths I have reached. So for example, if I have been to a cat and then to an owner and then to his addresses and then to the third address and then the text of that address, if that is different, I would like to have it stored here. So I'm going to store each object I see and use in my algorithm, and I'm going to store it here. That's the idea. Okay, so I have a constructor here. As you can see, this class is not used. I just wrote it, so we're going to use it in a minute. We'll have some initial names. That's the names of the objects. And I will have a result here. I will consider that the objects are true by default, and if I hit a failure, I'm going to change them to false. And I'm going to show you a little trick I'm going to use here. I will have an error path, which is essentially the path of the string. Not sure whether I'm going to use that property, we'll see. And I will have the different values I encounter in the algorithm. So for example, if the nested object is different, I'm going to store it here so that I can retrieve it in my error message. Good. I have two methods, apply path, which essentially adds the expected path part to the expected path parts and the actual part to the... I have a bug already. I'm disappointed from myself. So if I have an actual path, I'm going to add it here. And I will have a method which says apply values, which just receives the objects, the expected and the actual, and it's going to save them here. And the simple trick I'm going to use is I'm going to create an implicit operator bool, which allows me to convert deep equal result object to a bool without casting. I believe that's a widely unknown trick, but if I create an implicit operator like this one, I will be able to cast the two objects and use them without casting. So if I have a deep equal result, for example here, let me show it, I can say easily bool some value a new deep equal result. And of course I need to provide some data for the constructor to work, but as you can see, I can save into the bool that object because the C# compiler knows how to cast from the deep equal result and to get a bool. And it's very easy. I just say return just the result. It's a very neat trick which allows me to write something like that. Deep equal, return new deep equal result dot success. So even though I'm returning bool here, I can still return the deep equal result. And in this way, I'm going to rewrite my trues and falses to return deep equal result. And all my code will continue to work because essentially everywhere I'm using booleans, but by allowing the compiler to cast that object to the boolean value, I'm not going to need to recompile everything and rewrite everything to validate deep equal results. I will need to validate the bool value. So that's a nice trick we can use here. So let me return that. So how I'm going to use that deep equal result? I'm going to write it here, and I'm going to have a deep equal result object which is passed here and there in the recursion. So this will be one object which will accumulate all the path parts I'm validating, and at the end I'm going to have the result here and the path values which are different. So I'm going to add that object here. Then what else I'm going to need? Of course, these methods will not work because I will need to pass a new deep equal result object, but I'm going to do that later. Okay, so here I'm going to return deep equal results, and it starts to get wild. We'll fix them one by one. Okay, so the whole idea here is to... Actually, I'm not sure whether I will need that. Let's leave it like that and we'll see whether it's needed or not. So, I'm trying to compare two objects. So I'm going to start from the top. I have objects which are, for example, title equals cat, and another object which title equals cat. So what I want to do, I would like, when I first call these methods, I would like to say, hey, everything is fine by now, so apply the next values I'm going to validate. Save them. I'm just saving the objects I'm going to validate. Good. Then when I check for no, and if I want to return true, I can return result success. The idea here is to have result success pointing to this, and when I cast it to bool, it will get the result property which is initially true, which is kind of nice. Then if I call result failure, I'm going to set the result to false and return this. I'm returning this so that all parts of the recursion can use the deep equal result. That's the idea, because if I return true or false here and there, I will not be able to pass the result to. So I'm going to use it like that for now, and it will allow me to easily return true or false by just saying result success or result failure. And if I want to say result.failure here, I will see that the result will become false, which is essentially what I'm trying to achieve. Okay, so we're continuing down to the algorithm. I see that if I already visited the element, I return true. So here I would like to say result.success. Good. Then I check whether the expected types are object, and if they are, I receive result. What was that? That should be false, so result failure. Good. Then I check collections, and this is where it gets more interesting. So I check collections and I validate. Expected as enumerable is expected, so I will need the result object here to deep equal result, and I will need to return it. So I'm going to say return result dot, this was false, I believe. Yep. So deep equal result, and deep equal result or result. I'm going to say return result dot failure. I can make the opposite operator. I can make the boolean to be casted to deep equal result if I want, but it will not do the job here, because if I write public static implicit operated deep equal result from bool, and I just return some deep equal result like that, I will my code will start working, so I will be able to return false where I expect deep equal result, but I'm not going to be able to retrieve the actual values and all the paths I reached. So for now, I'm going to leave it, and it will show me all my compilation errors. Okay, so if these enumerables are not fine, I will return failure. Okay, good. Here I will need to also return failure, but I'm going to start writing the path, because currently if I have some sort of an array, I check its count property. And what I need to do here is I need to save that the failure comes from the count property. So I'm going to say result apply path. Let's add another method here, because essentially if the path is the same on the expected and on the actual objects, I don't need to provide it twice. It's the same. So I'm going to say expected path parts add path, and this actual path parts add path. So this will allow me to say the current path I want to add is the count name. Apply the count name, then apply the values, because essentially we have a failure because of the values, and the values are different. I'm having this one and this one. When I reuse a property, I like to introduce a variable. So I'm going to do that here. It will improve my code readability. And I will need to do the same for the actual values, which is count here and here. So if I have a collection with different kinds of if I have a collection with different kinds of different counts, I'm going to say that the count is the problem here, and that's why I'm having a failure. And I'm having these different counts as values. Great. But I'm going to make our code a little bit cooler by just introducing these two calls. This way I'm going to be able to write return result dot apply path dot apply values and then return the failure. Is it working? Oh, why is that void? Oh yeah, okay. So return this. Cool. After all, I'm building a freaking Fluent API, right? So let's make our code fluent. Cool. Next, what we have here, we validate with link whether the objects from the values are deeply equal. Cool story, but I would like to have a path like this. Get.owner.addresses tree, which is the tree.text. So essentially, I would like to show the end user that the third address is wrong. So I will need the index here. So maybe I would need to rewrite that. I will need to use plain old for cycle. So I'm going to say for loop list of expected values dot count. Great. Then I'm going to say var collection is equals true. Then I'm going to say if this, which is essentially the check, if the objects are not deeply equal, then apparently the collection is not equal and I found mistake, so I will need to break. And then I'm going to validate it like that. So I'm not going to need that anymore. And I will need to say list of expected values from I. So let me check that. I mark the collection as equal. I start each of its elements. Start navigating each of its elements. Great. And I validate that element. If it's not deeply equal, I say false. If it's deeply equal, it should be true. So it's fine. And if I find an error, then just break. Do I need to break? I can just return false and return true if everything is fine, right? So I will check. Let me see that again. Yep, that's correct. So I don't need that extra variable here. I will just return false if these are not equal, but I will need to pass the result. So I'm going to enhance by saying that I'm using a result here and I'm calling it here too. So it won't be mad. And I will need to provide the result too. Okay, but if it's false, what I need to do? If it's false, I will need to add and say result apply path. So I will know why it's false and I will apply path like this. My idea is to have the problematic property. Okay, so return result apply path dot failure. Do I need to apply the values? Maybe not, because are not deeply equal. We'll apply them. Okay, good. And otherwise return result.success. I don't need to write success, but I prefer it to make the code more readable. I would like in 2 years from now, when I open this code, I would like to see, oh, this is failure, this is success. Great. I have a feeling that this thing here will not work, but let's make the code compile first, and then we're going to validate whether it's working, we're going to debug it, and so on. Okay, so collections are deeply equal. It needs the result here. So collections are deeply equal, it should return the result. Then, if both types, if one of the type is not anonymous and the other one is anonymous, result failure. Do I need to tell the path? No, because I'm in the root object still for now. Here, again, result failure. Okay. Return result. I don't need to do anything here because the expected and actual are already added here. This algorithm is going to have so much bugs. I'm just assuming that we're going to have a hard time debugging that, but it will be fun. Bear with me. I'm calm for now. Okay, then we have a bool operator. So var equal operator result equals that. If that's true, if equal operator result false, if that is false, I will need to add the path equal operator. Okay, so let's write that. Result.apply path. And I will need to say that the equals operator is not fine. How to do that? Maybe like this. And I'm going to say equals equality quality operator, something like that. If the end result looks ugly, I will change it. But for now, if I have that's bool here, and I'm returning, but I don't want to return. Okay, let's return bool for now. But shouldn't be returning it like this. Okay, so actually let's use the bool and we'll see what we're going to need. I can say return true here, but I prefer return success. Okay, that's great. That's completely fine. Result failure, that's fine. Return that, which is why it's failing, essentially. Then we have another var equal method result. Good. If it's not true, I would like to apply to say that equals is the root cause of the problem here. Comparables. Okay, comparables. If everything is fine, great, but I'm going to pass the results too. I will need it. So let me check. Let me return bools for now, everywhere. Bool, 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 great. Everything is bool. Cool. Then I'm going to return to the comparables and I'm going to pass the result too. And if comparables are deeply equal, I will return result success. But comparables are deeply equal. This method is called, okay, yeah, got it. If the compared to result is false, we know the drill. We need to say result.apply path. I'm going to say method name equals to compare to. I'm going to say apply path compare to, like a method call. Result apply path. Okay, I'm going to leave that false here because if it's not comparable, and if it's not comparable, essentially the object is fine. This false does not mean that I'm failing here. It means that I need to continue below. I'm thinking right now. What I can do is I can say that when I call success, just to make my code the code consistent. That's the whole idea here. So I'm going to return result success, and I'm going to return result failure. Let's see. I'll need to check that later if it's not working. So good, I'm going to return result success. And if object properties are not deeply equal, so I will need a result object here too. So I'm going to say deep equal result. And I'm going to add it here. So let's see what's going on here. So I'm checking the properties. Each property I check, I will need to attach it. So I'm going to say result.applied path expected property. Where do I check whether the properties have the same count? Do I need to check that? If I have expected properties which are, for example, 3. No, actually, I cannot have different number of properties, because if I have different number of properties, I have different types, and I already checked that. Okay, so it's fine. I will apply the path, and I will say the path is the key, which is the name of the property. And if it's unnumerable, we should check it as collection. Cool. And if it's not deeply equal, return result failure. Sorry. Then I'm going to validate whether the properties are okay. And if the properties are different, I'm going to say return result failure. Otherwise, I'm going to say return result success. So result failure. I've added the path. I believe I added everything which is needed for now. The problem is that it may be fine for now, but dependency. So I believe the code is compiling now, which is kind of okay. But it most probably have some errors. So let's first validate whether we've broken our logic by changing a lot of stuffs and changing true and false here and there. So I'm going to rebuild that and see whether it's working. 0 failed. Really? It should be working just because I essentially replaced every true with result success and every false with result failure. So it should be working, but just to be sure, I'm going to run some more tests. I'm going to run these, and these. These tests are my application samples, block and music store, which contained quite a lot of useful unit tests, the actual unit tests people are going to use if they use my tool. And these just validate model state, routing, and pipeline like action filters, which again use the same method. So I'm going to run everything to make sure that I didn't broke the algorithm. Oh, the famous problem with the .NET. So I need to kill my .NET host like this, and I'm going to run tests again. I don't know why, but sometimes Visual Studio don't close the process of the .NET Core, and it fails to build the next one because the DLLs are still in use by the previous process. And when you try to build them, it shows you error that it cannot copy the output. It cannot copy the output, which is quite strange actually. While the tests are running, to solve that, you need just to kill the previous .NET Core process, but sometimes a restart is required. It's very strange. So I would like to thank my sponsors while the tests are running, because as you may already know, these projects are developed in my free time. For example, currently it's Sunday. So I'm open for all kinds of sponsorships or help. Currently, I have these 4 sponsors: Softuni, Smart IT, Noble Hire, and 1-Bit Software. Thank you guys, you truly rock. If you're looking for a job or just want to take a look at what these companies are doing and what kind of solutions they're providing, you may check their sites. And I would like to thank my special sponsor, which is giving me quite a lot of help with reach and with backlinks to my projects. That's Bellatrix Test Automation Framework. It's essentially the same tool I'm building, but for QAs. My tools are for developers, unit integration tests, acceptance tests, business layer tests, and so on. And these tools provide UI testing in a very cool manner. So if you're interested in tests, make sure you check them out. Great. Now let's continue, and all tests pass. That's kind of nice. Good. So essentially we changed our algorithm without breaking it. That's huge actually, because the algorithm is kind of hard. Okay. Next step is to see whether the deep equal result contains seemingly okay-ish values for the path, if for the expected and the actual, because I believe we will have 2 or 3 bugs. I'm sure, almost sure about one, but usually with these kind of algorithms, they don't run from the first time. But we're going to check that in my next video. So until then, thank you guys for being with me. I hope you enjoy watching me implementing this feature, because actually it's very fun for me to implement it, but it's double the fun when I explain it and when I know that somebody is going to learn something from me. So I'll be very happy if you find these videos helpful. Hit the likes button or subscribe if you haven't already. Thank you, and see you guys next video.